Welcome to your video on adding and subtracting polynomials. Again, this can be found in your red booklet on page 3. When we add polynomials, this is actually something that you already know how to do. What you're looking for is just the opportunity to combine like terms. Now, if you've forgotten what like terms are, they have to have the exact same variable part. So in our first example here, we have two polynomials. So this is polynomial number 1, and this is polynomial number 2. The only reason there are parentheses around them is just to show that they are grouped together as a polynomial. But that being said, we are completely allowed to break them up. So all you have to do is identify what terms are going to go together. So I'm first looking, the other thing to consider is that we want our answers in standard form. So let's just add that up here. I almost forgot to mention that. So if you forgot what standard form is, highest to lowest degree or exponent. So I'm going to kind of try to take care of both of those things in one step. So I'm looking at the highest exponent on the variable to be the x squared term. So I'm just going to identify that those two things are together. So 5x squared plus 2x squared is 7x squared. Next, I'm going to look at the x to the first power. And so I notice that this is an x to the first, this is an x to the first, and so is this. So I'm going to combine all of those. So a positive 8x and a negative 7x is a 1x. And then when I add 13x, that would give us 14x. Lastly, I want to look at the numbers or the constants. And I notice that negative 3 is the only constant. So I put that at the end. There's nothing else to combine it with. So the final answer for this problem is 7x squared plus 14x minus 3. When we subtract, the only difference is that we have to distribute the negative. And that's just like a negative 1. We could put a negative 1 in there. So I have 16x plus 14. Nothing happens with this first polynomial because the number in front of it is a positive 1. But the second polynomial, everything is going to switch signs because I'm taking negative 1 times all of these terms. So I have negative 3x squared. Negative 1 times x is negative 1x. And negative 1 times negative 9 is a positive 9. Once I've done that, all I look to do is combine like terms and then standard form again. So I'll say combine like terms and then write your answer in standard form. So looking for standard form, I want to start with the term that has the highest exponent. And right away, I notice that it appears to be this negative 3x squared. There are no other x squared terms, so I just write that down first. Next, I'm going to look for the term with a degree of 1. So I see here I've got a 16x and a negative 1x. So I put those together and I get 15x. And then we end with our constants. And 14 plus 9 gives us a positive 23. And notice I was just smart about combining like terms so that I automatically had my answer in standard form, just a little bit less work. So those are the only two examples in the notes. to finish up our understanding of this lesson, I want you to turn to page 15 toward the back of the booklet, and we're going to look at another warm-up. Now, it may have been a little bit of time since you studied the first lesson, so I would like you to work out this first question. Press pause, jot down your answers. You may need to look back at page 1 where we have the chart so that you remember how to name the polynomials. But it's asking us to first write it in standard form and then classify, which remember needs a first and a last name. So press pause, do your answers, and then resume when you're ready to check. So standard form means highest degree to lowest degree. We take all the signs that are in front of the terms. Remember, they're attached. So standard form would look like this: 3x to the fourth minus 2x to the third plus 6x plus 1. Now the degree name means I have to look for the term with the highest degree. So that's this term with the 4. And looking at your chart, that is quartic. You could also say fourth degree. And then number of terms, there is 1, 2, 3, 4 terms in this polynomial. And anything higher than 3 just gets the generic polynomial name. So this polynomial is considered a quartic polynomial. The second question, describe how to add and subtract polynomials. So again, I want you to think about the notes that we just wrote down. Press pause, jot down your answer, and then press play when you're ready to check. So adding and subtracting. When we add, we are going to combine like terms and then write our answers in standard form. When we subtract, we have to distribute the negative sign and then combine like terms and write our answer in standard form. Hopefully you had something to that effect. All right, now here's our practice, and this will help us as we get ready to do the homework. So when you run across problems like this, the directions are just going to say, perform the indicated operation. In this case, our only choice is to add or subtract, so you just have to identify, are we adding or are we subtracting? So problem A is a subtraction problem, which means this negative has to get distributed. So I am going to bring down the first polynomial because I am not changing anything about it. There is a positive 1 in front of it, and if you distribute a positive 1, nothing happens. When we distribute the negative 1, however, we have minus 7a to the second plus 8a minus 10. The negative is going to switch all of the signs. Now we're going to combine like terms and write that in standard form. So I'm going to start with the a squareds. That gives us 9a to the second because a positive 16 and a negative 7. Now I'm going to look at the a's. So I have a negative 12a and a positive 8a. That's going to give us a negative 4a. And then finally, we're going to finish up with the constants. A positive 1 and a negative 10 is a negative 9. Part B is just an addition problem. So we can just start with the like terms, and we want to look at the terms with the highest degree to begin. So I have a positive 14v and a negative 2v. So that would give us 12, I should have said squared. 14v squared, negative 2v squared for 12v squared. Now let's look at the v to the first terms. So positive 3v, negative 4v. That's a negative 1v. And then lastly, we're going to look at the constant terms. Negative 7, positive 7. Uh-oh. Those are going to cancel out to 0. So you can either write plus 0 or you can just stop there. At this time, I would like you to press pause and try to do example C and D on your own. And then when you're ready to check your answers, press play so that you can see if you were correct. So for part C, we have a subtraction symbol, which means we have to do some distributing. So the first polynomial is left alone. the second polynomial, we have to switch the signs because we are distributing a negative 1. Then we want to combine like terms, so 10x squared and a negative 10x squared. Well, those are going to cancel out, so I have 0x squareds left. I'm just going to get rid of them. Then I look at the x terms. I've got a positive 2x, but there are no other x terms to combine, so I leave that alone. And then lastly, we're going to look at our constants. And a negative 8 and a negative 8 is a negative 16. So our final answer is 2x minus 16. Part D is an addition problem, so that's fairly easy. We just have to look to combine like terms. And I want to start with the term with the highest degree. So I have a b to the 5th, and there are no other b to the 5ths, so I just write that down. Then I go to the b to the 4ths. There are no other b to the 4ths, so I bring that term down. Then we go to b to the 3rds, and there actually are no b to the 3rds, so we can skip that. Now let's look at b to the 2nd. Finally, I've got something I can do here. A negative 4b to the 2nd and a negative 6b to the 2nd combines to negative 10b to the 2nd. Now we can look at the b's. You can put your invisible 1 in there. A negative 2b and a negative 1b is a negative 3b. And then finally, we have our coefficients, or I'm sorry, our constants, negative 7 and positive 3 leaves us with a negative 4. So this concludes your notes on adding and subtracting. Oh, just kidding. We have one more problem in the warm-up. Sorry about that. I wouldn't want to leave you without working on these shapes. So perimeter, that is a word we have looked at all year. And just a reminder that a perimeter means we are adding all of the sides. So for our triangle, we have A plus 2A plus 2A. So I'm not even going to write this out. I'm just going to notice that when I add all the sides, I have to combine like terms. So I'll just add that up here, combine like terms. So I've got 1A, 2A, and 2A, which is 5A. Then I look at the plus 3 and the plus 3, and there's no number on the other side. So I put those together, and I get plus 6. Now, our next shape. This has been an issue all year. It has 4 sides. Only 2 sides are labeled, so don't make the mistake of calculating the perimeter only using 2 sides. Label your other 2 sides so that when you calculate the perimeter, you are counting all 4 sides. So again, we're just going to combine like terms, and I want to put things in standard form, so I'm going to start with the variable term here. I've got 2d plus 2d is 4d plus 6d is 10d. Then we want to add our numbers together. So a negative 3 and a negative 3 is a negative 6. Negative 4 and negative 4 is negative 8. Negative 8 and negative 6 is negative 14. And if you are just like, oh my gosh, that's too much math to do in my head, you of course have access to a calculator. There's a calculator on your computer. Just add up those numbers. Just remember that there's a minus sign in front of all of them. So now this concludes your notes, and you are now ready to go back in your booklet to the practice and work on the adding and subtracting.